All right, today's session is going to be a recorded session, so go ahead and we're going to give the presentation and then allow you guys to submit any questions throughout the presentation, and we'll address those at the end. All right, well, let's go ahead and get started, guys. Welcome again to today's weekly webinar. Today's topic is called Stop the Cloud Cost Madness, Graviton, AWS, and Qubole. We will help reduce your data lake cost using the next generation of processors provided by AWS in combination with Qubole data lake platform. So for today's session, we're going to go ahead and give you a quick introduction to Qubole and our presenters today. And then at the end, we're going to go ahead and open up to Q&A. I am David Stewart, the account executive here at Qubole, joined today with Brian Flug, one of our lead solutions architects. So Qubole at a glance was founded in 2011 from a couple co-creators of Apache Hive. And since then, we've had huge market success with growing from over 300 customers using our data lake platform, processing in excess of over an exabyte of data per month. We are a multi-cloud, multi-engine supporting AWS, GCP, Azure, as well as Oracle's cloud. And by offering the best of breed Presto, Spark, Hive, and Apache Airflow for orchestration of big data processing needs. Where Qubole leads in our customer success is our ability to avoid cloud costs. And Qubole is a recognized leader in the marketplace backed by hundreds of end user reviews in various marketplaces. We are an innovative technology solution that helps complete the Idera data fabric story. And one of the actual major reasons for Idera's strategic acquisition of Qubole in late 2020. Idera's data fabric story actually ensures its success by providing a comprehensive tooling ecosystem that optimizes the functions of data architecture, data governance, and data analytics to ensure key deliverables, including improved efficiency and availability, improved security and governance, as well as reducing costs and risk. And the Idera data fabric story is achieved with a combination of some of Idera portfolio data products, including Aqua Data Studio, which is a universal IDE for databases and visual analytics, ER Studio, which is an industry-leading data modeling tool, designing and understanding data assets, Warescape for data warehouse automation and orchestration, and then Qubole to round off the data fabric offerings by providing our customer with a data lake component for data pipelines, ad hoc streaming analytics, machine learning, and AI workloads in any cloud.
Thank you, David. My name is Flug, and I'm a solution architect with Qubole. And myself, having had decades of cloud computing and the evolution of cloud computing from a performance standpoint, today's topic with the Graviton 3 is extremely exciting for me. So let's just dive right in. To start out, if we just take a look at the Qubole platform and the capabilities, the left-hand side going up this stack, we got storage, compute, platform capabilities, and access. Okay, access. Depending on your persona and what you're doing in this analytical solution, a data scientist or an analyst or an admin, keeping this platform running, you have all these disciplines, whether it be machine learning, AI, and deep learning, or reporting, and traditional BI and visualizations in an analytical view, or obtaining the data from an engineer standpoint, ETL and preparation, ingestions, and then a data admin, keeping a platform running for all of these different disciplines. You look at the platform capabilities required to do that. And that's what we see in this center area. And I'm not going to go into each one of them because we're going to demonstrate them throughout the day today. And then the important thing that all of this capability to do these type of functions and operations on data with an analytical purpose require a compute engine. Compute engines always require data, of course, the storage, the data lake. But what we're looking at today is the compute engines These compute engines require physical logical hardware, the Graviton 3 integrated chip circuit design servers. And that's kind of what we're focusing on today, is a little bit of the compute, or the compute. So looking a little bit deeper at the open data lake, Qubole data lake platform or fabric, on the left-hand side, we have your data lake, whether it be existing years of warehouse data or enterprise data or current capturing of streaming data. That data is available in the cloud. And all 4 cloud providers, once your data is cloud enabled, you have an objective to deliver it on the right-hand side to maybe a common UI, to interact with it, to look at it, to quantify it. You have other tools and components with an API or an SDK, or traditional ODBC or JDBC connections with various other technologies to view, interact, consume that data. And in the middle, you have what we're looking at today, a data fabric, allowing you the computing infrastructure with this hardware and new hardwares we're focusing on to do and manage and compute this data in an analytical fashion. And the Qubole platform having these components, as you'll see today, to explore, analyze, to track, have a dashboard, workspace, cluster config. That's a little bit of what we're going to focus on because of the Graviton 3 architecture. Okay, so what is the Graviton 3? Graviton 1 and 2 is a type of, it's an IC, it's integrated circuit in a backplane processor, designed and developed over time from the Amazon cloud web service providers, looking and monitoring how we use this cloud and why. They're exclusively tailored for things like big data, AI, ML. The evolution of Graviton 1, 2, and 3, you'll see, and where we're at today with Graviton 3, bringing all of this together. I mean, Amazon is now a chip manufacturer, like Intel, like AMD. They have their each own chipset. And even from some of the early days of big data and Hadoop, the goal was to have it on a chip. And Amazon is bringing that to the table, really. If you look at Graviton 1, 2018, kind of some of the initial things, security, enhancement capabilities, workloads, some of the core fundamentals were developed on Graviton 1 that were continually added with the Graviton 2 to expand it from a performance in these instances, from a general burstable compute, SSD optimization and storage, and Graviton 1 and 2 together, even in the 3, bringing up to 40% price performance in an Intel base. Now with Graviton 3 being the AWS chip and the whole architecture of a server and a rack, explicitly designed for what Amazon does on the cloud and offers for our customers. Looking at the Graviton 3, including things like the Neoverse and a bfloat, which I'll briefly introduce, bfloat 16, which is an Amazon solution. It's a physical, logical thing inside these servers, in these racks. FPGAs, field programmable gateway controllers, which if you look at some of the earlier days of even pre-cloud and supercomputing, a single rack of an IBM box would have 250 of these FGPAs in there, doing specific things from a high performance level. Well, that technology is coming to the cloud and much more with Amazon and even Outpost and the extended fabric adapter. It's all a byproduct of their Graviton investment in their own chip and design and integrated circuit research. Why Graviton 3? Well, it kind of brings everything together, looking at the Xeon when you buy a server and it's stamped with Intel or AMD, and now they'll be stamped with Amazon, Graviton. The general purposes are really everything. And if you look at this thing said P99 latency, all of this together is really breaching another level of compute cloud capacity. P99 is a rating of latency, which you can just think of it as compute across the wire. From here to there, I got a clock cycle in one part of the country that's going to communicate to a clock cycle across the world. And how is that done? And what is the limiting factor of doing that? And that's a measurement called P99 latency. Prior to this, we were at 256 roughly with the Amazon architecture. That's cut in half. That's significant. And these are the purposes. A little note, burstable, compute intensive, memory intensive, graphic intensive, high performance storage, IO, GPUs and FGPAs, and the level to compute at the IoT blockchain level, we're going to need this type of architecture. At some point, you're all going to be on Graviton. We all will, probably about the same point that the qubit starts to show up, as Amazon as well has a big investment in developing quantum computing chipsets and architectures, physical boxes put together, which is, here's the ARM chipset. And it's kind of, what is physically all this? If you think of a chipset and this rack of things here, the Amazon Graviton 3 and the racks and the outpost all put together in a logical physical fashion, we're taking the fundamentals of, you could say, Hadoop on a chip and deploying it as if it was a supercomputer on premise on the cloud. What is the difference? The connectivity to utilize data and compute cycles. The evolution of even some of the architecture of the software technology, and now the outpost to include focus on various big data storage engines and NoSQL and Hadoop type distributed architecture. What used to be done on-prem is now going to the cloud globally, and I'll point that out here in a moment, which is the Neoverse and the ARM. It's basically being refactored and architected and manufactured as the Graviton family from Amazon. And we talked a little about FGPAs, GPUs, software on a circuit, IC design, big data on an IC chip. The beginning of Hadoop, both AMD and Intel invested significant because the ultimate goal is to have big data distributed, parallelized architecture. We kind of grew up in a serialized world on-prem for the most part. Yeah, SQL and Oracle racks were all serialized in their compute. They weren't a supercomputer because that was big, expensive, and way off the cuff. But now where we're at, refactoring it, all of this together brings this, to this little picture here, which is Hadoop on this little thing. And it's explicit little chips just to illustrate the integrated circuit and the advantages of the physical compute. Not so much the compute engine, Spark this, Hive that, Hadoop that. Yes, those are important technologies, but they are limited to the hardware and the physical deployment of that hardware under the hood. We're now breaching 75 plus gigabit backplanes, InfiniBand. They're connected by multiple wires, beams of light, which is like a DWDM. So the communication speed. bfloat 16 is a double buffering that is in the architecture of the Graviton 3. It's physical components soldered in the backplane of a server. Looking at why and where this starts to fit in, scientific, obviously, we know the medical and the genomic worlds, we can't compute fast enough. And this really breaches and takes us to another level. HPC, ASIC, additional computer infrastructure, biomedical, machine learning, CPU intelligence, analytical intelligence. Stop there a little bit because it's not your traditional machine learning you might think of it. It's a processor that's going to remember, I saw this data before. Hey, I'm going to hold on to it for a while. It's not really code. It's not some script. It's built into that little chip you see right there. Analytical intelligence, same rules where I'm seeing this pattern. Okay, now I'm going to do this more often in a compute cycle, and I'm going to store and cache memory and clock cycles. The EFA, FEA, EDF, the IDA. I think we're evolving to something like the idea of data fabric, the extended fabric adapters for the extended data fabrics, the IDF. Okay, so now we're going to jump into a real live demo and show you how Qubole can help you and show you if and when you actually need a Graviton and how to use it to its full capacity. So what I've done is I've logged into the Qubole platform here, and I'm at the Qubole platform as a service, and I have a cluster. It's already running. It's been running 27.
Hey, Brian,
yep.
we're going to show your screen. Sorry.
Oh, sorry. Yeah, I wish we were sharing PowerPoints. Okay, so sorry about that. Thank you, Dave. Okay, so what I've done is I've logged into the Qubole platform as a service already, and I fired up one of these compute engines. And it's been running, 27 minutes. Okay, this is our platform as a service. Here's our main menu. And I'm going to quickly go through utilizing our platform with the focus on how to use Qubole to determine when and if I need a Graviton, and then as well, when I get to that Graviton, to consume it at its highest efficiency. They're expensive. The goal of the Graviton is you get a greater degree of performance over a shorter amount of time on your workloads at a higher cost. So it's a kind of a balance act. So to start out here, I have a cluster, and I've just logged into this cluster, and we look at it, it's a Spark cluster. It's been running 28 minutes. Here's the boot up process. This is the cluster homepage. Some of our customers will run, one individual will run 25 clusters, consuming 200 to 250 nodes in a 2-hour period. Running on all of our engines. We have multiple engines, and I'll go into that in a little bit. The focus is going to be, how does this thing help me with Graviton? So to start out, I have a workload that I've been typically running in my environment that captures data, analyzes data, gives me some results, prepares that data in some relatively compute intensive workloads, some joins of millions of rows. And I started out with this particular small cluster, those 2 node, and I've selected this hardware instance. Okay. I've selected some scaling capacities, and I've obviously selected some scaling options, but I've selected some very slow hardware on purpose, because I want to know when I need the Graviton, and I want to make sure that what I'm using today, I'm using it to its full efficiency before I even determine if I need a Graviton. So to do that, I'm going to run my workloads. So logging into my environment, the first thing I might want to do is I have some data here that I use and is available that just showed up. And this happens to be some genomic data that I just want to perform a simple row count and determine how many rows are in this. So I've logged into this platform, into the Qubole as a platform. I'm going to my analyze window. I'm just going to select my cluster. There's my cluster I want to run this on, and I'm going to say run. And while this kicks off, I'm also going to go into a workload, and I have a workload here. This is a very well-known workload. Everybody seems to use what they call the hacker database, which is about 11 million rows of data. And we're going to analyze some frequency visits of various events based on a time window of different news broadcast stations. I think everybody's Google and everyone's used this data set. And I'm just going to run this. I'm not going to do anything but run it with the intent to see some performance and actually measure when and if I need a Graviton. So I'm just going to say run and say run that. And I also have another notebook that is it's a production level like notebook, as you can see in our notebook environment. And this one does some custom churn, and it's determining some happy customer internally if I'm delivering my analytics to them or not. So I've kicked off these 2 production level workbooks, and I'm also going to real quickly go in and join 10 million rows of data and kick that off on this very small, inexpensive cluster and see what my results are. Okay, so I've kicked off these jobs and they're running, and this is a typical production environment. We're not using any just average data. I can go deeper. Let's just step back and go take a look at my cluster. So I'm going to go, for example, to a home page. Shows there we go. Okay, sorry, it shows me 1 cluster running. I got some things running. This is our Qubole as a service homepage, and some other stats about the notebooks have kicked off, how long the clusters. Like I said, some of our clusters, a single individual will log in and have 25 running, depending on their workflow, and they will scale up from 0 to 200 and back, 3 times in a typical work shift. So let's take a look at this cluster. Let's go pick on it and see what's happening. Okay, now back to our cluster home page. Here's my cluster, 6.3 811. Let's real quickly go in and take a look at some real-time dynamics. And here you can see I've kicked off this cluster and there's 2 nodes with my master. It's not really working very hard. The 2 red nodes are breaching. We're getting to the point where we're going to need a couple more nodes for some performance. So let's continue and maybe kick off another. Let's check our jobs here. They might have been done quicker than I planned on. I'm just going to kick off another query on top of this cluster to tax it a little bit more. So I'm going to go into my home page, and here I'm going to go into my analyze environment. And with the Qubole environment, there's different panes to share information and share snippets of code based on the languages and clusters that the engines support. All of it, again, running on hardware. Whatever engine, whether it be Spark, Hive, Presto, Airflow, it all comes down to the same hardware fundamentals from the cloud provider. And that's what we're focusing on here. And I'm loading up this cluster intentionally with some real world data to show you how you got to measure that. And you can see now we're changing, we're red a little bit here, 34%. I'm hoping I'm going to request another node here. So let's just go back and check a couple things. Okay, we got our cluster running. I think my smart query was joining some rows, that's running. Okay. My custom churn job looks like it's still running. Let's just give it a minute. This other production notebook probably is finished. Did I run this one? No, I didn't. So I apologize. I didn't kick that one off. Looking at some analyze here, this job came back. I counted a little genomic set of data, which 24 million rows of data. That's not a small amount of data. And a row is almost equivalent to a record, especially when it's all a string. And in this case, that's what this data was. It was already ingested. And how long did that take just to look at that? So it took 79 seconds. Okay, so now we have some numbers and we can see we've taxed this little very, very inexpensive off the shelf piece of hardware, and we're grabbing a couple nodes even. So now that we've taxed, and this is Gangula, there's many ways to view the status with the Qubole platform. And without doing this, you really don't know if you need a Graviton, because joins and broadcasts and the unification of data with code is what causes us to need more compute. You look at blockchain, the larger, the faster, the better you got to compute. Exactly. So, and the emphasis from Amazon and all of the cloud providers is utilization efficiency, to do more with less and to have a higher degree of compute utilizations. You'd be amazed at how many 100 node clusters, instances are sitting out there idle 60 to 70% of the time. And you'd be amazed. You really would. Both even on-prem, it's always there. It's always eating electricity, square footage, and everything. So, but the advantage of the cloud is to eliminate that. So you can scale up, scale down, almost like stepping on the gas on a boat or an airplane. So I'm just letting this run a little bit. Okay, so let's get a little update. We've jumped up to 41% and we've grabbed a couple more nodes. So we're obviously starting to use these compute hardware to its maximum. Now that we have that data, now we can determine when and if we want to use a Graviton or change our instance. The instance selection inside of the cloud providers is still kind of, you could say, early cloud stages. Because as it evolves, each and every application will get smarter and better to know when a different particular instance on a particular different performance network, 2500 gigabit per second backlane, will change the equation. And things like IoT and blockchain are going to force that to happen because of the nature of the data and how that's communicated from a scaling efficiency standpoint. I'm kind of just letting this run a little bit. See, okay, now we're really, and I did this on purpose because now I know I've used my nodes to their max capacity. I'm still only hitting 40, But as you can see here, if I look at my 1 minute interval, I'm at 154% utilization. Therefore, I need additional nodes. And in some cases, clusters, nodes, all this, it's the supercomputer on the cloud, if you will, and it's distributed unlike on-prem, but to scale and add more nodes on demand can be way more efficient than having many nodes sitting and waiting. There is a balance act. And always, if you are scaling on a need versus a demand, there can be a difference. So, and this is what we're doing here. And a lot of our customers, our significant customers, do this. I can show you customers that go from 0 to 200 in 3 minutes, get the job done and close it down. Boom. Downscaling, very, very important as well. So I'm just kind of letting my jobs run on purpose here. We kicked off a couple, few million row joins. Let's even go back and take a look. So look at our cluster. Let's just update this. Up to 3 nodes, spot nodes. And this is a little bit, this is the demand, this is the real-time view. So we're grabbing nodes. Things are happening. Let's go look at my smart query. That was where I was joining 290 million row records. That's still running. I'm just looking at it from a user standpoint. Inside the cluster now, another component is you look at the resources. There's Gangula, which is this what I've been looking at. This has been around a long time, came from supercomputing. It's quick, it's fast, it's easy. It really shows you what's going on. You can drill in real deep. Our leading customer uses this for the exact purpose, what I'm doing now, to quantify their compute utilizations on how they use their infrastructure, their compute with data and code. Because remember, data is data. You're not going to change data. How you use that data, you can have sloppy code that doesn't use efficient compute resources and vice versa. So it's a balance act of the right code and the utilization of that code on that instance. Remember, it all comes down to physical stuff. Spark engines obviously perform better, but the real added value is the physical hardware. You can change things 10 to 1 just by different hardware, and using it efficiently. Let's see where we're at now. 61, we're jumping up a little bit. Okay, and some other nodes are calming down. You can see there's some things happening. This is a nice little visual. And just to look, we only got 32 processors. This particular instance, my server next to me is faster. Pretty close, about the same. But again, that's on purpose, because if I can't completely utilize what I got, why would I need more to start with? And then how do I determine any return on what I'm going to go get, like a Graviton 3 or even a 2, where I'm going to grab more horsepower? It fits into ROIs and everything if you really looking at it from a pure consumption utilization efficiency standpoint. So, okay, let's go back. I want to see some results. We're pretty close, I think. Yeah, this one finished. So here's the 90 million join, 489 seconds. I think, yeah, that's probably my best time. I think there's a range. I think the worst case I had is 503. And I think this is, it can vary. It depends on how you're selecting your nodes and some other intelligence that your platform has to have. The Qubole platform has cluster scaling intelligence built into it from a logical and a physical perspective, even to a patent standpoint, where we have some patents that go back close to 10 years on how to scale along this fashion from a, if you think about it, the faster I go up straight, the faster I'm using things. If I go up granularly, I'm kind of slowly dragging into it, okay, let's do some compute. Instead, you go up straight, you're utilizing everything efficiently from a compute data code balance, because bad code can slow you down, speed you up, as well as slow, inefficient hardware. So, okay, let's just stop here a minute and pause. 59, we're starting to slow down. Jobs are completing. Boom, boom, boom. Now we're into this intelligent downscaling. And garbage collection, volatile memory cleanup, all these kind of things are starting to happen. let's just take another look at our cluster. There's some other components like the resource manager. I can drill into how many executors and how much memories and cores I used on any particular job. I can also get a dashboard report on every command, a Spark command, a Hive command. What did it consume? And that can evolve to looking at this from a compute standpoint. Okay, then a couple other things. We can just look at some other, I can look at a status of this cluster. There's some other components from there, we can see the size of it. As I mentioned, to have a higher degree of smaller, high performance configured nodes, workers, can increase your performance significantly. But it's a balance act of what kind of data size, volume, and physical mapping of this data architecture down to the physical hardware. As we looked at from the the Graviton 3, just quickly looking at this, from a physical BIOS firmware layer, the OSI model operating system level. Okay, how are we for time? I think we're okay. So I want to look at some of my results. Let's just, here's that smart query. It's done. Let's look at it. Everybody talks a good story. Show me something. Hey, where is it? There it is, right there. And we just joined 90 million rows. Let's look at I ran a couple of these jobs. This one here finished. We looked at this. This counting, and this was some genomic data that we counted that just showed up. So now let's just kind of step in and go look here for a moment. So if we go look at our cluster, and let's just drill into maybe if we're going to create a new one. Now we have some data that we can determine what kind and what is the best type of instance we may need for this hardware, and how we can use a Graviton based component. If you look here, there's a lot of options here. A lot of them change significantly. 48 cores, 384 gig of memory. Well, if you have that instance and you don't use it correctly, it's going to slow you down. So it's a balance act. And even going deeper, where if I have a system, we talk machine learning, CPU intelligence, well, my CPU is going to learn that I need more memory in this case. I'm backing up with a backplane, an L1, L2, a buffer to cache limitation, because every cache goes to a buffer because it's all a 0 or a 1. So the whole math model of the compute backend is that of nature. So how to determine that? Well, machine learning. Maybe I can apply some machine learning to my own cluster and have it learn when I may need a Graviton. Absolutely. Right now in this particular demonstration, the Graviton, as we looked, let's just step back and leave this and kind of take just a little review on what we were looking at here. We look at some of the history of, the Graviton. 218, 219, that's not a long time ago. Where we're at now, bringing it all together. The adaptability. Some of our customers are just now starting to look at Graviton 2 and other and implement it in a more performance, efficiency workload type of deployment. And as a Graviton 3 now, which is a big leap for Amazon, because it's not just chips and other Intel-based chips with Amazon technology, it's their own server, it's their own backplane put together with the Graviton 3. That brings the efficiency at the table to look at how you use compute today. So, and depending on what workloads and what components the Graviton is. And we have a much deeper presentation on the Graviton in some other fundamentals that we can go into. And right now, we can support 2 right now if you need it. We're in the midst of quantifying and QAing Graviton 3 with our latest release, which is what we call our R60. At this point, I'm going to stop and say, do we have some questions, comments?
Yeah, it's a great point to stop, Brian. We'll go ahead and open up some of the questions that have been submitted while you've been giving your talk. So One question came in is, does Qubole support Graviton today? That's a great question. With this, yes, we will be able to support Graviton 1 and 2 chipsets in our next release, as Brian mentioned. It's coming out soon. And then down the road, we will be able to support Graviton 3. So,
and we're testing all the above in parallel right now. We're showing all of the intelligence thereof.
got it. Okay. The other question is, can you intermix instance types of Graviton and non-Graviton?
Absolutely, and that's another advantage of the Qubole and configure architecture. For example, what's this say right here? Use multiple node types. Okay, so example, like right here, I can specify different instances, and I can even store them and use them in a containerized fashion based on my demand, my workload that I've been learning from using this platform. I can add multiples here. You can see I can add different types here. I'm just picking a few off the cuff because there's many.
Absolutely. Okay. Well, great. The next couple questions coming in. It's when is R60 going to be released? Well, yes, R60 on right now, the latest word is going to be for March 5th for our North American customers. We are in the process of releasing it to some of our other instances, environments across the globe. And so the latest release is be early March. So that's that. Another question, do we have any price comparison between Graviton and non-Graviton? Well, the instance types is going to be based upon your cloud provider or on AWS for that. From a Qubole pricing perspective, it's going to be the same as we do license Qubole per QCU, Qubole compute unit. That would be what you would pay for Qubole service.
And just briefly showing you, we utilize our own tool to do analytics as well. So we're using a Qubole platform, and we have workbooks that are analyzing that as we speak right now in almost a pseudo real-time fashion.
Absolutely. So another question, it's pre-release availability. Yes. So you can, if you're a Qubole customer, you can work with your customer success manager on access to our early pre-release program, and they will be able to connect you with that when it's available. So, and I think the other question is, do we provide a trial version? Yes, actually we do provide a trial version of Qubole, and it's very easy accessible. Let me go ahead and go to the next slide, Brian. We'll go ahead and leave you guys with a couple of resources and white papers that you can reference about our workload aware auto scaling capabilities that Brian had demonstrated today. And as well as you can reach out to myself direct at david.stewart@qubole.com. Next slide, you can see that email address for more information. And then we'll also follow up with this webinar with the link for the recording if you like. And then as well, you can go to qubole.com/free trial, and that will get you set up. It will essentially create your account on Qubole, and then you can connect it through the easy steps with your own data lake data. So, all right, I think that's it's going to be for today's session. We appreciate everyone for showing up and questions. Anything else, we'll love to hear from you. And thank you for your time today.